other cloud providers like Azure, um, Google Cloud, Oracle, etc., Alibaba Cloud, and many more. But we are going to focus on the AWS Cloud because AWS is the market leader, and there is a huge demand for the AWS cloud skills. So we will focus on AWS Cloud. Once you know one cloud, learning other cloud will not be a big deal. And if you have not made the payment, I think now you have the link. You can go to tamilmedia.org/academy, and there will be a link how to pay. There's a section you can make the payment. Thank you for the support. My name is Armugam Pichimuthu. I'm a solutions architect, and I know, part of the cloud. There is nobody who knows the fleet of services that's available in the cloud. And I focus mainly on the database services of the cloud. And for the introduction purpose, I will cover the common infrastructures like identity access management, storage, and VPC, maybe some few things. But later, I will be able to go deep onto any databases that are offered in AWS Cloud. So last week we saw what is cloud computing, right? It is like electricity, if you want to compare, right? Where you don't worry or you don't know how it is being manufactured, how it is being distributed, but as a consumer, you can consume it whenever you want. You turn on the switch and you get a light or any other utilities working. That's all you care about. So similarly, in cloud computing, you don't own the sophisticated infrastructure like networking devices, storage devices, or powerful computing devices in any of your premises, but you rent it kind of, you subscribe to that service and pay as long as you use it. Once you terminate it, you no longer are going to be billed for those services. That's the convenience of cloud computing. Now, since we are focusing on AWS, let's look at the history of AWS, how AWS was started. It's all part of Amazon, right? Amazon Web Services. That's what AWS stands for. Amazon does the business at a very large scale, and their e-commerce business itself requires a lot of IT infrastructure and the agility at which they can, deploy things, meaning how fast they can make changes and how fast they can deploy things in production. So for that, they were coming up with some new automation tools and the automated way of building their infrastructure, like any other companies do the invention, right? But what was different at Amazon was there were two guys, Chris Pinkham and Benjamin Black. They presented a paper in 2003 which said, how we can quickly deploy, build and deploy the infrastructure, like how to scale elastically up and down when there is a need, there is a demand for the resources. And once that paper was, accepted, then Amazon decided to sell that as a service. Why can't we sell this service for everybody, all the business people, and make their life easier? Then Amazon decided to launch a very small and simple service. Started with SQS, very simple service. SQS stands for Simple Queuing Service. So queuing is a way of designing application where you don't have very tighter integration between two applications, right? It is a loosely coupled architecture design. One application sends a message by putting a message into the queue. The other application will be listening and consuming, reading the message from the queue. So queue is like a database, but it is not very persistent, or it doesn't need that much maintenance and all. It's faster. You can keep the things in memory. So that is the service they built first, and they let the consumers use it. And then they came up with many other services: SNS, simple notification services, S3, and many more later. And just looking at the important events in the history of AWS, in 2006, officially AWS was launched. Amazon Web Services was launched as an official service for people to subscribe to the services and consume that. Since then, they have been leading the cloud market very strong. And in 2007, they had 180,000 builders. The word builders means anybody who goes to AWS console or their service and start building applications and systems, those builders. And why should we focus, why should we consider AWS, right? I can buy my own computer. I'm a tech savvy guy. I can build my own computer. I can run my own database. I can run my own network and operating system and everything. Why should I go there? But see, look at the way when a startup company wants to start, they don't know, first of all, they're going to succeed or fail. So why invest so much, right? And then how to liquidate all those assets? So in that scenario, the startups are people, somebody who wants to try out a new experiment, right? It can lead to failure also. They don't want to invest a lot of money. They just open an account with AWS and subscribe to the services that you want. When I say subscribe to the services, you buy the compute services, you buy the storage services, and you build your product or whatever concept you have in mind very quickly, right? In minutes, you can spin a computer in AWS. So for those kind of early startups and people who want to experiment new concepts, this is the place, right? If it doesn't work out, just close the services, take your toys, and leave the place. That's it. You are no more being built for the services that you have terminated. That's it. And it is safe and secure, that we saw last time also. And pay for what you use, which means today you want 10 virtual machines, so you spend 10 virtual machines. But tomorrow your need goes down to, say, 4 virtual machines. You can just shut down those other 6 virtual machines, and you will be billed only for those services that you are using. Okay, it is not a bulk one-time investment, and you don't have to commit any long-term commitment. Well, there are a couple of subscription patterns where you can opt for longer term commitment. See, as a big enterprise company, I know I'm going to run for next 3 years. So I can say, hey, I'm going to make an agreement for 3 years with AWS. Can you give me discount? So you can come to an agreement, negotiate the price, and run long term if you want to, but you don't have to commit. And then some of the, from the business perspective, how does it help to move into cloud? So we already saw increased agility. So agility means the speed at which you can make changes, you can deploy things, right? You can, in cloud, you can automate your code build, your infrastructure build, so that it happens over hour, within hours. And in a traditional world, when it comes to the capacity, people budget for their entire year. Okay, so for the year of 2020, for the capacity that I need for running my infrastructure in December 2020, I would have paid that money, or I would have kept that money aside as a budget in January 2020, right? So 1 year ahead, you are making that capacity planning and estimating that money and keeping it aside, which is not a great use of money. So when you come to cloud, you don't have to do that. You subscribe to the service again as you need. If you don't want it, trash it, right? You don't have to have that big budget. And the third point is also, capital expense. Just to give you clarity, there are two kind of expenses, right? Capital expenses and operating expenses. CapEx and OpEx. So capital expenses, a huge investment that you have to make, like buying data center or buying servers, and all. You don't have to do that anymore. And breadth of services that you get in an AWS service, right? Say you have a transactional system where people are making purchases, and you have the history of all the purchase, but you want to do some kind of data analytics, or build a data warehouse, then again you have to invest on powerful compute infrastructure. Whereas, let me close my windows. When you move into the AWS cloud, you get not only the hardware. Think about the ETL software, the reporting software, right? All those things are available, built in, and you can just subscribe and use it. So data warehouse is one small example. Consider data lake. Right now everybody, all the big companies are talking about data lake. Um, Give me a second. I forgot to start recording. Ruben, have you started recording?
Yes, and I have started.
Okay, thanks,
It's
Ruben.
been getting recorded, so
Okay, thanks, Ruben.
sure.
And so you don't have to worry about, oh, I have to build some strong authentication, authorization infrastructure. Everything is available in AWS. Just use it. And then now you have customer base here in US. Later you want to expand into Asia, Europe. Okay. So now what happens? Your application will respond slowly. You have a big latency for the customers who are coming from across the continent, right? If you want to give a better experience for those customers, you have to build a new data center or lease new data center in Asia and Europe, which is the traditional case. But in cloud, you don't have to do that. You just say, hey, I'm switching, rather I'm adding another region, right? Europe region or Asia Pacific region. And there you can build your ecosystem over there. And you can have continuous replication happening back and forth in terms of storage, in terms of database, and also you can spin off applications, dedicated regions, and you can have the high availability HA and the DR plans set up. So you can automate that whole thing, which is tested and proven by many other companies, and you don't have to reinvent the wheel again. So this shows a high level picture of the presence of AWS across the world, right? These are all the point of presence. So the ones that you see in orange color circles, these are all called regions. Okay, so if you focus on US, which is on the left side, you have um, number three, number two, number six things in inside a circle, right? So that means each region has that many number of availability zones. We will see what is the availability zone, but just imagine it is a highly redundant infrastructure. Okay, and the green circles mean these are all new regions that AWS is planning to expand into those geographical regions. So there is a presence in almost in all the uh, places wherever humans live, right? Um, so US West has three regions, US East has four regions, etc. We saw a point about the breadth of
The
services.
quickly, sorry. If you go back to earlier screen, right? Same geographic area itself, I can see the eastern US. It has two threes, right? So that means
Yes.
region three they have two zones or something, or
So yeah, so let's take number six, for example, and make it simple. Number six means that is a region itself. Okay, so the it is called um, US East region. Okay, so in US East there are four regions. In US East there are four regions. Number two, number three, number three, number six. When you say four regions, so what does that number six mean? It means it has six um, subset or availability zones, they call it. And number two represents it has only two availability zones. So what is an availability zone? Okay, so that's how AWS plan their global infrastructure. See, for example, I used to work for some a grocery business company in IT industry. Um, it's a retail business, and they had their data center in Phoenix, Arizona, and they had only one data center building in Phoenix. And if at all anything happens to that building, then that entire data center is gone. And they built a DR data center in Virginia. That becomes a secondary, right? So let's focus only on the primary data center they had in Phoenix, Arizona. That is just one building. If that goes down, the power goes down, or the building comes down, then the entire infrastructure is down. What AWS does is they build multiple independent buildings, and then based on the geographical proximity, they group those data centers into availability zones. Okay, there could be one in Phoenix, there could be one in Gilbert, there could be one in maybe Tempe. Okay, they are all a close proximity, but they are isolated with a decent distance. And they group them and call it as an availability zone. So what does an availability zone or AZ means is it's a group of data centers, and they make sure the customers have a highly available infrastructure setup. So one building goes down, that's not end of the world. They have other two buildings in next cities. So when three data centers make one availability zone, and consider the region US East 1 has six such availability zones. There are n number of buildings, n number of data centers in one region. So region is divided into availability zone, and each availability zone has multiple data centers. And there are certain area where they have only two availability zones. And it could be many reasons, that there is not much applications or customers running their applications over there. Um, Usually three is a very common number. Three availability zones is very common number. So even if two go down, there will be one running. So in case there are two availability zones in that region, in US East region, you see number two. Wherever you see number two, if one availability zone goes down, which means like 3, 4 buildings or whatever number of data centers in that availability zone goes down, still there is another replica that has this services running. That AZ will hold the services.
Thanks, Aru. So basically, the two means as you mentioned, right? It's a kind of broad, the prod DR setup. One goes down, you have one more available zone, so that your service will run with no interruption. Three means you have two backup location kind of thing. When you say six, that means there are six backup kind of location. That means highly critical applications, right? Those are even, I mean, they can sustain even 5 zones are down, still they have 6 zone to support.
Yeah, even 5 going down, the 6th one will support. Yeah.
Yeah, okay. And at the same time, seeing the another one in Asia, there is only one. So that means that particular one, there is only one availability zone. That means probably there's a newly built or something. I don't know why it shows one. So that means there is no availability at all. In case there is a failure, then the data center level failure, then there is no backup service available.
It's a great question, Durai. That kind of refreshes my memory a bit. Why there is one, right? There is another 4 and 2 nearby. I think it is Japan. Okay. So the Japan. Okay, let's step back. Okay, one step back. In a region, you have multiple availability zones, and availability zones within a region mean high availability. The name itself says it is availability zone, which is meant for high availability. It is not meant for DR. A DR can be a big earthquake, or it can be a big flood or storm happening in that region, and it can bring down all the availability zones in that region. I mean, we have not seen so far yet in AWS or any other cloud provider, but it is possible, right? So when you want to build a DR solution, you have to go across the region. You have your primary in US West. You will consider US East as your DR location, not in the same availability zone, not in the same region, but you will go across the region. When it comes to US East, say you are running your primary, you can consider either US West or Europe, across the ocean. There is a highly unlikely chance that Europe also will go down when US East goes down. So going across the region means it is a DR. So what happens when you build a DR? There are possibilities. You may have to go across the continent, correct? When you take South America, there is only one region there. And if they want to build, a customer running in South America wants to build a DR, they have to consider either North America or Europe or some other place. But in case where you see number 1 in Japan, there is another region which has 4 availability zones, and they want to build a DR, but the government says you cannot take the data to a different country. So AWS built another region within the same country to provide the DR support. So the AWS products and services are mainly driven by customer demands. 95% of the services and features that is available in AWS is completely driven by customers' needs. So it is a region set up only for DR purpose.
Okay, got it. Thank you.
Yeah.
And also initially I thought that the numbers are availability zone identification number. That's not the case. It's the number of availability zones available within the region. Thanks
Correct.
for the clarification.
Yeah. Thank you. And this is the breadth of services we saw, right? What is the primary goal or reason to move into cloud? Okay, so this is only a sample of services that AWS provides. Okay, there are a lot of services every year. New services are getting launched. Okay, let's focus on some important services, right? Let us take a look at. Oops, the bottommost one. It's called infrastructure layer, where you see.
Sorry for disturbing. One quick thing. Are you using a dual monitor or something, Aaron?
Yeah.
Oh, okay, because even though I go to full screen mode, it comes within half of my screen. I'm not sure there's something you can correct it or not.
It's not able to fit, you mean?
No, it is. It is not. I'm not getting the full screen completely within my monitor. Probably you are exporting both of your monitors or something like that. So the picture that you show, that
I'm sharing only
fits.
one. I'm sharing my one screen.
Oh,
Anybody
okay.
else
I
have this
see.
problem?
So I don't
One
know
side I see.
what you may have to do is go back to PowerPoint and move the picture image a bit towards up, because the bottom part is getting cut. Like under the infrastructure,
Okay.
just move that picture a bit more up.
See, now I hold PowerPoint. I see within half of my screen, right? The other side I see your logo and someone is speaking. Their names are coming up in other half of my monitor.
Is
The
it
whole
good now?
presentation.
It's better now.
Oh, still. Yeah,
Okay.
but still it is within half screen. I don't know. Anyway, I don't want to waste the time. Yeah, I thought.
Okay.
Yeah, I think it's because of the PowerPoint template as well. So.
Okay.
How about
Yeah,
now?
no,
I think
still
it's
have the
only
screen.
at my end, Arup. I could able to see entire picture. Even me, I'm seeing the whole thing. I don't see any problem.
Yeah,
Okay.
I can see the whole thing.
Okay.
It's
Let's
good
move
now.
I
on.
don't know. Then
Today
maybe
I'll
my
share the
problem. I'll
content
go on.
anyway. Yeah.
Okay.
So let's look at the infrastructure side, right? We are like 9:42 now. Okay. Regions and availability zones and point of presence. So point of presence means like edge locations, right? We'll see what is an edge location. For example, you have some content to be delivered to your end consumers in, say, a rural area, somewhere in Ramanathapuram district, right, or in Thoothukudi district, where there, there's not a big presence or data center available. But there can be small buildings with some cache servers. It's called edge locations. Taking the service to the edge and bringing it closer to the customers. So those cache servers or edge locations, they will cache the frequently used contents locally. Somebody wants to look at some picture that's going viral at that time, so that gets cached over there. So the frequently accessed or the consequent access will be served from locally. So that is the point of presence thing, but that is a smaller footprint. But the availability zones and regions are very critical. And on top of this infrastructure, then the next layer of things are built, like the compute layer. I'm sorry, this picture is not very clear. Compute layer, which has the virtual machines and lambdas and other things can be run on this. And then the storage, where you want to run your file sharing or your databases, whatever you are having. S3, right, is the one storage, very popular storage service. And then the content delivery network. You remember we talked about the point of interest having the data cached, that is using the content delivery network. And then databases. So databases itself is a service. There is a bunch of database services that Amazon provides, AWS provides as native solutions. And then the networking components, right? When you put everything into AWS, how do you make sure your data is secure, right? How do you make sure your the guy who has his service, your neighbors, it's not touching your servers? So you need a strong networking isolation. So for that, there are certain things like VPCs and subnets and things like that that will be deployed. So those services are built on top of this global infrastructure. Then once these core services are built, then you have other services like identity management, right? How do you control the access within your company itself? And then how do you control the access? And you want to encrypt the data. Then comes the key management system. How do you, somebody steals the hardware, how do you make sure the data is encrypted? So then the data at rest encryption comes into play. And then data in transit encryption also comes into play when there is data flying within the network. Then how do we monitor your application and the audit logs and things like that? So all those services are built on top of the core services. Then you have tons of service, which I may not be knowing all these services myself, but um, so these are like, if your company is stepping into AWS, they have access to a lot of technical and business support in the left side. And oh, a lot. Data warehouse. See, under analytics, in the center of the picture, there is a data warehouse, Hadoop. You can build your own big data ecosystem over there. And then how to capture the real-time streaming data that's coming from IoT devices. Last week, we saw what is an IoT device, how they send the data. So all these services are available in AWS. These are just to name a few. And imagine the benefit the customer gets, right? I want to set up a database and application. I start here, and then I can start using all the services and integrate one another, and make sure the backup is happening and the access control is taken care of, etc. And last week we talked a lot about security. What are the compliance programs? So these are some of the compliance programs. You can go to AWS website and read more on what are the security compliance programs they offer. Somebody was asking, is it HIPAA compliant? Yes. And PCI. Okay, now let's look at some of the key services that's available in AWS. So security is very important when you go out of your house network, right? So when you are putting your data in the cloud, how do we make sure the identity of the person who is accessing is, he has the access, and he is the person who is intended to access. So that is controlled by identity and access management service. It is a full-fledged service offered by AWS, where you can create your users and permissions and things like that. Then other important services, storage. Everybody, end of the day, wants to store the data and process the data, right? So storage is a key thing. Then next one is compute service. Okay, so the compute service is, without compute service, what you are going to do with your data? Maybe you can only share your pictures and audio, video, and things like that. But if you have real data that you want to crunch and make some meaning out of it, then you need the compute service. So these are some of the key services that's available. When we talk about identity access management, there are four key components. Users, you create users within your organizations, and then you set your password policy and all those things. And you also grant access to users on some specific services. We will see some of these things in a hands-on demo, so I will not spend too much time over here. It's better to spend time on the practical sessions. Then you can group those users into groups, and you can uh, assign certain roles to the users or groups. Say, I want to give admin role to these users, or I want to give developer role to these users. All those things you can control within identity and access management service. So it is a centralized control, right? A way of controlling your access and identity. And once you create a user, the same username will be available across the globe. It is a very global object. You cannot say, I want to have aru at tamilmedia.org in US West, and also the same idea you want to create in Asia Pacific. No, it is one single object. And you can set the password policies, like how often they should change it, password rotation, how strong it should be, and things like that. And then multi-factor authentication. Hey, I want to protect whenever somebody wants to log into this critical account, whoever is having admin roles, they cannot just enter password and get through. They should have second level of authentication on their phone or something like that, where we will send a one-time passcode and they enter the passcode, and then only they'll gain the access and things like that. When it comes to storage services, it is also uniquely identified. It is a service. It is like API web service. S3. S3 stands for, I'm not sure if I told earlier, S3 stands for Simple Storage Service. And there are three S, so they call it S3. And when you create storage, it goes with a bucket. It is like your drive, right? At home, you have in your computer, you have C drive, D drive. Similarly, you can compare. It's not exactly the same, but you can compare. One bucket is like your drive. Under that, you can have folders, and it is uniquely identified across the AWS ecosystem. And S3 is used for object storage only. What does object storage only mean? Which means you can only dump files. Okay, you cannot use it for creating your databases. For databases, you need block storage, and S3 is not block storage. And you cannot install an operating system in the bucket, in S3 bucket, right? It is simply to dump your files and then share those files. And you can keep the version control enabled. So by mistake, somebody uploaded a wrong file with the same file name, you can track down the old version, and you can revert back to your older version. And it is also called key value pair. I have not mentioned in the bullets, but key value pair. What does a key value pair in S3 mean? Which means the file name is a key, and the content inside that file is value. Anybody does not know what is a key value pair? One simple example, right? When you're filling some application, you say there is a question, your full name, that is a key, and you type your name, that is a value. And they ask what is the date of birth, that is a key, and you enter your date of birth value, right? That is a value, key value. So similarly, S3 is a key value pair storage, and you can access it using console CLI. CLI stands for command line interface. It's a short form. Or APIs. API calls means application programming interface, which means within your code, you can call those S3 APIs, and you can, for example, have you ever used FileZilla the FTP, SCP file transfer tool that can upload files to S3. There are many tools now started supporting S3 to upload and download files, and it is very secure. It depends on how you manage the security on your files. It is available, all the mechanisms are available, and you can encrypt the data. So if anybody by mistake download that data or get hold of that data, they will not be able to unencrypt it without the key that you have used to encrypt. Any questions on that S3?
In key value pair, right? Generally, yeah, I mean, any parameter with value, that's what we call it as a key value pair, as you mentioned, the first name, then actual name. When it comes to S3, the file name is basically key and the whole content is treated as a value.
Correct.
Okay, so, okay.
Yeah, it's a little different in a way how we used key value pair, but it logically makes sense, right? You have a file name and you just ask for that file name, you will get the content. That's the value.
Another thing I have that S3 has a security and encryption. So the previous slide also identity access management, right? It has a roles, policies, all these things. So again, it's coming as security and encryption, right?
Right. So these are different services, right? So here you create the users and control the users' access.
Okay.
At user level security, you define at the IAM.
This is the user level. Okay.
And here it is the storage level. Just because I have access in my company account doesn't mean I can go look at all the payroll data. So there are different levels of access and identity management or data security
Okay.
applied, right?
Storage level. Okay.
Yeah.
Okay.
Then it comes to compute service. Let's look at only compute service as a virtual machine. Okay. Now let's not mix it with the IAM or S3 service. This is a virtual machine that you created in AWS. What are the types of virtual machines you can have? You can have Windows or Linux. Okay. And you can configure the size of your virtual machines, how many CPUs you want, or how much memory you want. It goes hand in hand as a ratio, but you can choose the size of your VM that you want to use and what version of operating system you want to use. And all those operating systems come included, it is license included. You are not going to pay extra money for those licenses in most cases. And you don't have to worry about installing, patching your operating system. That is all done for you by AWS. That's the beauty of spinning your own virtual machine. Okay, you don't have to install. Installing operating system sometimes it is pain. And you can attach block storages. EBS stands for Elastic Block Storage. What does it mean? It is similar to your hard drive. Today I have a machine and I have like 2 terabyte hard drive. Similarly, you can say I want 2 terabyte hard drive in my cloud. Or you can always say I want to start with maybe half terabyte and then I can expand on that or add more EBS block devices on that. So that is similar to your hard disk in your home computer. And you can have security groups to control access to your services running on EC2, right? What is security group? It is a new concept in AWS. Many of you might not have heard that. It is nothing but firewall. You might have come across the term firewall in your company. That is the equivalent of security groups in AWS, where you say, this is the source and this is the target, and I'm opening this port number, port 84443 or port 5432, from this source to this target. Okay, and virtual private cloud.
Before you go to virtual private cloud, the security groups, right? When you talk about it, by default, any image is completely isolated due to micro segmentation, right? Unless you explicitly open certain port, that port is not going to be open due to micro segmentation, right?
Correct. Yeah.
Then what exactly the security group? I mean, basically here you're grouping the collection of machines, saying that, I mean, open the ports within these machines, open all the ports within these security groups, something like that.
Yes. So, yeah, that's a very good point you touched upon, but it is a kind of advanced topic for most of the people here. So let me see how I can answer. Yeah. The main difference between your data center or the traditional way of we do the computing and the cloud computing is that the moment you come into cloud, there are millions of users, right, in the cloud, and security is the key. So the cloud design is that by default, all the ports will be closed, all will be locked, and you have to open each and every port that you want to open it for the applications to interact. That is a major difference when you migrate from a data center into cloud. You should know each and every port that application needs, and you have to open all those ports one by one. That is a key thing. And then when it comes to security groups, say when you are building an application, your application may need multiple ports to be opened to database server and from your web server, considering a 3-tier application. And for SSH, you need some access. And then for 443, and maybe something else is running on Java. Java is listening on something else. .NET is listening on something else. So there are bunch of ports that you have to open. Each port opening is called security rule, and the group or the collection of all those ports is called security group. So you say security group, which means it will have one or more security rules in it. That's why it is called security group. Hope it makes sense.
Yeah, it makes sense. Even if in case if I want to open all kind of thing within my 5 machines, I create a group with open all, then apply the group security group, then 5 machines can communicate with each other with no restriction.
Yeah, yeah. You can group them as a logical grouping. Yeah.
Yeah, thank you.
And the next important thing when it comes to the networking is virtual private cloud, right? Which means now you are in the public cloud, but you will feel safe if you have your own private network, isn't it? That is why there is a virtual private cloud concept. This is to tighten the network security by means of creating your own private cloud within the AWS cloud, where you say, hey, my machines cannot go out to internet. No, that's it, period. Or anybody from outside the internet cannot come to my servers. I locked everything by putting everything into the simple VPC. But I want only one machine to interact outside, and I want one machine to interact or to accept connections from outside, like Bastion host kind of thing, jump host also we call it, right? So those kind of things you can define within the VPC. Now you have the control of your entire network. You define what can interact, what cannot interact, because it is your own private cloud now. You can have separate subnets all kind of things. And you can keep your EC2. That is the key thing. You define all these VPCs and then say, hey, my EC2, which is nothing but your computer. EC2 may be a confusing term, but it's nothing but um, computer, virtual computer, right? Where you run your application or your database or your report, whatnot. That can sit inside a VPC, safe and secure. So you have protection and security at all layers. That is why cloud is more secure than data center many times. And when it comes to getting EC2 computers, you can get on demand, which is the very traditional way. I just want 2 CPUs and maybe 4 GB RAM. I will run it and I'll pay for monthly. But if you think you are going to use it for next 3 years or 5 years, you go for a reserved price. You will get it at maybe 40% discount. Is it not great, compared to what you get in your data center? And spot instance is very peculiar, where you can bid for price. Hey, I'll pay 10 cents per hour for one computer I want to use for whatever number of times or number of hours you want to use, you can use, but you can bid for the price, right? Isn't that cool? And if there is something available for that price, you will get it. But somebody comes and pays more, your instance will be taken away with a 2 minutes notice. But this is cool if you have some application that maintains the state of your data, um, and your processing gets stopped abruptly. You can come back again and rebid and get another spot instance and start your processing. So you can get more things done with a less cost. I hope I'm able to articulate that spot concept here clearly.
It's still not clear. That means probably if you can explain it, that would help. And also, it's abruptly stopping the service means it may impact your business, or probably it may be for development purpose where you need more computing resources with cheaper price, where you get the computing resources cheaper price using spot, and as long as it is available, you can do it. Then you give up.
Right. Yeah. So there are certain things which you can process in batch mode, right? You don't have to have your computer available all the time, where you will save the state of your processing, and when you restart, you can resume basically where you left off. Say you are running a payroll for 250,000 employees with say maybe 10 regions, okay? And at a time you process one region, okay? And when you are processing fourth region, your machine, the spot instance is taken away. You can again get another spot instance with a little higher price. Instead of 10 cents, maybe you will get it for 12 cents. Now you will get definitely one. And then say, hey, process from this fourth region or fourth cost center, and continue that payroll processing. What you will be paying is almost like 20 to 30% of the actual price of EC2. If you can design an application in such a way that it is loosely coupled and it can maintain its own state, then you can benefit using the spot instance.
Okay, got it.
Okay, and right now, quick time check. It is 10:10 a.m. in Pacific West Coast. Does anybody have any time pressure, or can I continue for another 10-15 minutes? Raise your hand if you have to go early. Okay, I assume nobody is under time pressure.
No, I think we can proceed. Thanks.
Thanks. And let's look at the important piece of the cloud. In AWS, it is called VPC, Virtual Private Cloud. Okay, these are all quiz questions. You have to take the quiz at the end. Okay, so pay attention. VPC stands for Virtual Private Cloud. So it is a private cloud within the AWS cloud, and it is meant for isolating your compute resources and securing it the way you want to secure them. And a customer can have multiple VPCs. There are some soft limits. Per region, you can have 5 VPC or something like that, but you can have more by working with AWS support, and you can build in another region also.
Aruna, just a quick question on the previous slide. Also, you spoke about VPC. So what's the difference between this particular VPC and the previous version?
So this is EC2. When you when you want to make your EC2 secure, you place it inside a VPC. That's why I touched about VPC here. So the same VPC, we are zooming in and going into a little bit more detail.
Okay, all right, thank you.
So here, when you see inside the VPC, you can have a subnet. Subnet is to group your computers, right? There is nothing magic. So you don't want to expose certain things outside, but you want to expose certain things for customers. Your web servers have to be external facing, right? So that your users can interact with your application. But at the same time, your database, um, as per the best practice, um, should stay behind some strong firewall. You don't want to expose it. And your application also should stay behind the firewall unless there are any other compelling reasons. So you divide all these computers into logical groups: web servers, application servers, and database servers, and then put them in separate subnets. And there are types of subnets: private subnet, public subnet, where the public subnets can be exposed to outside world and where your web servers fall into those category. And private subnets are not exposed. You have internal IP range, and you keep your database servers in those private subnets. We will see all those things in hands-on later. Don't worry about that if you don't get it. So just keep in mind, you can divide your computers into logical groups, and those logical groups can be called subnets. And you can have things interact within subnets by means of security groups and access control list, ACL we call it, and many things. And gateway. See, your computer wants to access outside internet. It has to interact with some other third-party application or service. Or you are building your own desktop, right? That is very interesting. You can have your own desktop in AWS. It is called workspaces. And you can look at the pricing and you can go for one and play around with that. But keep in mind, it is it will incur some cost. Okay, and that computer, you want to have internet access, say going to google.com, or accessing your emails and other things. I don't want to keep a computer in my room, but I want to keep it in the cloud. So you will go through the gateway, and you want to have some public IP addresses assigned. And when one computer goes down, you want to move that IP address to another surviving computer server. So that thing, you can do it with the elastic IP. So that's a typo. It is not elastics, but it is elastic IP, EIP. And access control list, we saw again to control the access from one network to the other network.
So basically, the access control is from one network to another network, and the secure groups are within the your VPC itself. You have to group collection of machines.
It is a little different. Access control list is, I think, it is a stateless, and security group is stateful. But we will see that in
Okay.
practical hands-on session. What is the difference?
Yeah, I can wait.
between those two? Yeah. Then comes to the important service, right? We all have worked on some or other databases, and database is a very key thing in modern computing time. And AWS offers wide range of database services. Let's see what are those. The RDS stands for Relational Data Services. Okay, so relational data services means whatever we are dealing with today as tables, which contains rows and columns, all relational databases, right? And there are other types of databases. That's why I said more. Others meaning NoSQL database, document databases, and right, hierarchical databases, graph databases, time series databases, ledger databases. So everything is available in AWS. Let's see. So when it comes to relational databases, the main databases are Oracle, Microsoft SQL Server, MySQL, Postgres. These are very commonly used, right? I'm sure most of you might have used it sometime or other in your company. And Aurora is another relational database service that was built by AWS. That was a purpose-built database, but it is a relational database. And it has two types of engines, MySQL engine and Postgres engine. You can pick and choose what you want. And Redshift is another relational database, but it is meant for data warehouse kind of purposes. Whereas the first line and the Aurora, they are all meant for transactional purposes, right? They're good for handling quick burst transactions. But Redshift's strength is to process huge amount of data for data analytics and data warehouse workload. And DynamoDB is a NoSQL database engine built by Amazon. It is similar to Cassandra if you have worked in Cassandra. And by the way, I am Cassandra certified, and I have worked as Cassandra admin also. If we want to touch more on Cassandra in the future, I can go in deep. And DynamoDB is one such, NoSQL database. It is not relational database. The data inside is relational, but it is stored in a different format. And Elastic Cache is in-memory database, right? So all these databases that we saw already store the data in disk, and they have to read from disk and write into disk. There is a latency, there is a delay. Whereas Elastic Cache contains services that are in-memory databases, which means the data always stays in the memory, which means it is always fast for both reading and writing. And then Keyspaces. Keyspaces is a new database that got launched, I think, in June in AWS. It is nothing but Cassandra, but it is managed Cassandra database in AWS. You don't have to create a cluster, maintain the cluster, install the Cassandra software, upgrade the Java, all those things. It is all done for you. You just click few buttons and then make your Cassandra cluster running. It is called Keyspaces. Neptune is a graph database. Social networking, who is connected to who, and other things like who purchased this product, and maybe you can recommend the same product to his friends or to his family. Those kind of use cases are used in Neptune kind of graph databases. EMR is Elastic Map Reduce, which is nothing but a Hadoop database, which is to process big data kind of workloads. I know this is too much to digest, but just keep in mind at a high level, AWS offers relational database services and NoSQL graph kind of database services. That's it. That's the summary of this slide. That's all I had for today. It is 10:20 in West Coast. Any questions I can go if you want to, but I think in one day it will be difficult to digest. But next session we will do some hands-on. I don't want to get into hands-on directly without knowing the concepts. So next week onwards, if there is enough registration and interest, we will consider hands-on.
Yeah, that would be helpful. Thank you.
Any questions on today's topic or anything general?
Oh, sorry.
We
I
will
was
close
sorry.
the
Sorry.
session with the quiz, the post-evaluation quiz. Yeah, go ahead, Rai.
Yeah, probably we can fix the time, 60 minutes or 90 minutes. Yeah, a little bit. Okay, going up, right? Probably you can, that way we know what is the schedule exactly. And also the next week hands-on, do we need to, currently the AWS access is free, right? So you're going to go over having the machine so that we can also, I mean, have a hands-on session along with you, or once you're done with that, we can have some kind of lab session kind of thing. How you plan to do that one? Considering AWS, it's free for everyone for 1 year, right? As long as the competing within the limit, we use the resources within that limit, right?
Yeah. So AWS has certain free services with a certain limit. You can create services for free on compute and storage. Storage is anyway very cheap. So you can create your own account and you can, but certain services are not free. You get 12 months free subscription. So you make use of that. You create an account, and from that day onwards, for 12 months, you get free access to some services, basic services, which are more than enough to learn. But I'm thinking next week I will share my screen and I will go through some of the services like IAM, S3, EC2, and I'll show you. And it can be interactive, and you can, practice those things later at your home at your convenience.
Okay.
Okay, and I will post the link for your post course evaluation, and try to finish that in, I would say, 5 minutes. Now, after this session, I think you are all AWS champions, so you should be able to finish in 5 minutes. You got the links I just shared?
Yeah, we have got it.
Let me go through. VPC we covered. We covered EC2.
Location. Which of the following service? Which of the storage services?
Senthil.
Oh, sorry.
And should I go ahead and stop the recording?
Yeah, we can stop the recording. Yeah,
Okay.
thanks, Ruben.